Sometimes variables do not have a perfect linear relationship. However, the general trend is linear. And so what we'd like to do is be able to find a line that fits that data the closest. And there's different methods for this, and the method we're going to do is we're going to find a line that's called the least squares regression line. I just want to sketch real quick what is happening here. So if we've got some points that follow a general linear trend but are not actually perfectly linear, like this might be what we have. And you see, of course, that there's not a single line that goes through all these points. However, there is a line that would fit fairly well, and that's the least squares regression line that we're looking for. So here's how we can do that. Here we've got an example. The sales of a company in millions of dollars for each year are shown in the table below. So we've got X are years, and then we've got these sales. We want to find the least squares regression line. In order to do this, we're going to have to use a special calculator that can do this for us. And a lot of different calculators can do it. We're going to use the Desmos Calculator. So in Desmos, if you go to desmos.com/calculator, it gives you a standard graphing calculator. And what we're going to do is we're going to first input these points, into a table. So we're going to click this plus and we're going to add a table. And then we're going to put in our X and our Y values. So X, we've got 2005, and 2006, and 2007, 2008, 2009. And for our Y values, those are our sales. We've got 12, 19, 29, 37, and 45. Now, you get to kind of decide how you're going to measure things. Now this was in millions, so if I wanted, I could go ahead and type in million, and I'm going to do that. Just because I want to be very clear about what my units are. So each of these in millions. So those are our points. We also, sometimes what people will do is they'll take the years and they'll kind of truncate those and maybe do X is 5, 6, 7, 8, and 9, and then maybe leave those Y values as just the in millions, 12, 19, 29, 37, and 45. It's totally up to you, but just make sure that you're being consistent in what you're doing. Now, in Desmos, the way that we do the least squares regression line, what we're going to do is we know that the general form of a line is going to be y equals mx plus b. And we're going to kind of do that here, but first of all, notice this is y1 and x1. So we're going to do y, and if you just type 1 in Desmos, it's just going to put it as a subscript. And then instead of equals, because it's not actually equal to a line, we do a little squiggly, and this is on your keyboard generally the number right next to the 1 on the left of the 1. If you hit shift and then that key, that will give you that little squiggle. And then we do our m times x1 plus b. Okay. And I want you to notice now that there's some things going on here, right, that are some numbers it tells you, It tells you an m, and it tells you the b. And this creates the line that's the best line. Now, because of the numbers here, these actually are huge numbers, and so maybe I'm going to change my units. Let's go back to, instead of millions, we'll actually putting in the million, we'll just leave the original numbers that were there. Probably was a bad idea to change the form of the question. Okay, so here are those, and if we wanted, we could change the years. Let me go and change the years as well. We'll just do 5, 6, 7, 8, and 9. Oh, and that was not what I wanted. Okay, put in our data, make sure that it's all showing up exactly how it's supposed to be. I'm going to go ahead and get rid of. Okay. So this is in the years since 2000, and this is in sales in millions. And you can see there's a line that showed up there. Okay, that's the least squares regression line. I'm going to go ahead and zoom out of this so that you can see that there's some points there. Now I'm going to go ahead and change my window on this just so it's a little bit easier to see. So from 0 to, we'll just go to 10. And our y values will go from -1 to 50. Okay, that'll give us a clear picture of this. We've got our different points, and you can see that the points don't fit perfectly on the line, but we found a line that is pretty dang close. Okay, so this is the least squares regression line. So the least squares regression line, I know that m is 8.4 and b is -30.4. So I go ahead and write those in here. So y equals 8.4x, and then plus b, which was -30.4. That's the least squares regression line. Part B, use the least squares regression line as a model to estimate the sales of the company in the year 2012. Now note that in this line, X represented the year since 2000. Okay, so if I'm finding 2012, now I'm talking about X equals 12. And we just plug it right into this equation. 8.4 times 12 minus 30.4. And I'll go ahead and just plug that into Desmos. Why not? So down here, use our calculator here, 8.4 times 12 minus 30.4. And we get 70.4. And so our estimate now would be that based on these sales, if the linear trend continues, we would estimate that the company has $70.4 million in sales in 2012.